So today I'll be sharpening my jointer and planer knives, getting them ready for the new school year. Instead of me just showing you how I sharpen, I thought it would be nice if I could just take you guys through the process of how I come up with these jigs and fixtures. Now I'm not here to show you how smart I am, but to show you how simple it is that anybody can do this if we just follow a few simple guidelines. Now I know some of you will say that, well, my planer uses disposable blades. Well, so are mine. A set of these blades cost me around $230. Now that's a lot of money seeing how many blades I go through here at our school. Here I have over $2,000 worth of blades. Now I'm not going to throw them away, especially when I know that I can sharpen them to a much higher grit than when it was new with very little effort. So the most important thing for me when it comes to making jig is the mindset. Now I learned this back in the days when I was taking engineering classes. I remember the first day when I went into class, there was 4 big letters written on the board, KISS, which stands for Keep It Simple Stupid. Now we all heard that before, but what does it really mean? How do we keep it simple? So for me, it just boils down to look for the obvious. Don't overthink it. Now that we have our mindset, we can proceed by using a process of elimination. So I always start off with 2 questions. The first one is, what tool are we going to use? And the second one is, are we going to be building a jig or are we going to be building a fixture? So to find the best tool for the job, again, I'm going to use the process of elimination. Now I've seen people use belt sanders to do their sharpening. For me, I think that's a little bit too aggressive for our purpose. Same with a disc sander and also an edge sander. So I'm going to eliminate all the power sanding tools. So what do we have left? We have sandpaper and also we have a water stone. Now I'm going to lean toward more the water stone because it has a harder surface and also it's all flat, which gives me a nice edge. Also, I can sharpen it all the way up to 8,000 grit. Now even if I can get an 8,000 grit sandpaper, I think it's a little bit too soft for me. Because when the blade actually makes contact with the paper, it has a little bit of give, and that could roll over my edge. So my obvious choice would be the water stone. So the next thing we need to figure out is, are we going to be making a jig or are we going to be making a fixture? Now, what is the difference? Well, from my understanding is that a jig is when your workpiece is actually moving and your tool is stationary. And a fixture is when your workpiece is actually fixed like fixture, and then your tool is the one that's actually moving. So what's easier for us? Is it easier for me to have my blade going across the stone or have my stone going across the blade? Now my planer blades are 20 inches in length and it's also very flexible. I think it's more difficult for me to keep this flat and rigid while going across the stone with even pressure and also with a consistent angle. I think it's easier if I just lay it down flat on something solid and have my stone going across the blade. So my obvious choice is I'm going to be making a fixture. So let's see if we can make this all work. So before we rush out to the shop and start cutting and making our jigs, I like to go through a few scenarios in my head to make sure that we eliminate any potential problems. So to start, I'm going to lay my blade down on a nice flat surface like this and move the stone back and forth until I find the right angle. Now I'm going to figure out how to hold the blade in place later on. Once I find the angle, I'm going to put a stop here and I can move the stone back and forth while I'm sharpening. Now that might work, but before I'm satisfied with it, I want to make sure there's no other potential problems. Remember, look for the obvious. So the first thing I might see a problem is it's going to be hard to keep the stone against my stop while moving. I might rock it back and forth and potentially changing the angle. So what if I make a carriage to hold the stone in place and maybe mount it to a drawer slide so it can move across easily? That would be kind of cool, but what other things can go wrong? Well, if I use it enough and being in one place, I can put a groove right in my stone and that's going to round over and ruin my edge. So that's not going to work. I need the freedom of my stone being able to move in different places while sharpening. So again, let's look at the obvious. Now I know that the angle is set by the distance between my blade and my stop. So what happens if I remove the stop, or better yet, just cut it off right here, as if it was like this? Now I have the freedom of actually using my whole stone and keeping my angle. Now I think we're getting somewhere. But what else can go wrong? Well, the stone will potentially wear out my edge. and change the angle slightly. How am I going to fix that? I can reinforce the edge by maybe putting a tape on it, or better yet, maybe put a stronger tape on it, or maybe just, I don't know, put some aluminum foil on here that will keep it from ruining it. Well, that might be a temporary fix because eventually the stone will grind it away. So back to the drawing board. The problem is the edge is weak, and the cause is the stone. So instead of fixing the problem, let's concentrate on the cause. The abrasiveness of the stone is a problem, so instead of protecting the edge with the aluminum foil, how about we put the aluminum foil over the stone like this? Now we have a smooth edge on both sides, and this will take a long time to wear down. So I think this might work. Now, how are we going to hold the blade in place? If we use clamps, you'll get in the way. Even if I put a thin piece over the blade and clamp it further back, it's still not going to work because this is too thick. This will get in the way. And even if I cut a chamfer on this, meaning cutting it down at an angle, there's still the clamping and unclamping. That's just too much trouble. So I need to wedge somehow without clamping. How about we just wedge it this way? Bring the blade down here and finding the angle so that the edge is actually parallel to the surface. And then we can put the stop back here like this, and that will wedge it in. Better yet, why don't we just cut a slot here and just drop it in at that angle? I think this will work. Time to make a prototype. So to make life a little easier for you guys, I decided to look into some of the more popular planers and jointers out there to see what angle these blades will ground to. And I found some similarities. The blades that look like these is actually ground to 40 degrees. This is for a jet floor model 15-inch planer. And this one here is for my general 12-inch jointer. And for the benchtop model planers, these are ground to 45 degrees. This is from a Delta. I'm sure that the DeWalt is probably the same, but you want to maybe double check it. And for the Felder, I found that these were ground to 50. Now, I'm going to start with the benchtop planer blades. I'm tilting the blade to 45 degrees. Use a piece of scrap wood to set the depth of cut so that the blade is sitting just proud of the surface between 64th and a 32nd of an inch. I make several passes increasing the blade height each time until I reach the desired height. Now take it slow and be patient with this. Once I'm happy with the result, I then move the fence to around the 4-inch mark and cut the real piece. I want to mention that cutting the slots for these thin disposable blades, use the ATB saw blade. It leaves a W kind of shape at the bottom, which is perfect for locking the blade in place so that it doesn't move due to the larger size of the saw curve. So the Felder blade is ground to 50 degrees. So that means I have to set my table saw to 40 degrees according to the table saw scale. Now that could be a little bit confusing, but I need to clear that up because when we do the actual 40 degrees, you just don't set it to 40 degrees and expect to have the same angle. It's not correct. So think of it this way. The scale on the table saw is actually a reference. When it says 0, you're actually at 90. So when you raise it up 10 degrees, what does that really mean? You're only 10 degrees off from 90. So you're at 80. So if I want to set the blade to actual 50 degrees, you have to think about how many degrees am I off from 90. So you go 80, 70, 60, 50. I'm 40 degrees off from 90. That will give me my 50-degree cut. Okay, we have to understand that the scale on the table saw is not the actual angle. It's just a reference of how many angle is it changing off of 90. Okay? So these type of blades are actually ground to 40 degrees in angle. This is for my 12-inch jointer, and this is for my 15-inch planer. Now to get a 40-degree cut, I need to lower my blade or tilt my blade to 50 degrees. Well, my table saw, or most table saw, only goes down to 45. So what does that mean? It means we're screwed. So here's how I solved the problem. Because the blade only goes down to 45, I cut the angle at 45, and I just want to make sure that the blade sticks up 1/8 of an inch. This way, I can change the angle of my stone by putting a block here to kind of compensate for that 5 degree. I'm going to be using a flat top blade to cut the grooves for these one-sided thicker blades. For those of you that have blades with a shallow angle like this one here, I want to explain how to get the right height for the block. It's very important. First, you have to find the highest point of the blade. Just put a square up against the blade and mark a line. From here, I draw the angle at 4 degrees instead of 5. This gives me the 1 degree secondary bevel. I then determine the width of the block I will be using. For me, it's 3/8. I put a square up to the block and strike my line. I then take the line and bring it down. I take this distance plus the height of the blade, which is 1/8. So I'm going to lower my square 1/8 below the angle line, and here is the correct height of the block. So here are my fixtures ready to go to work. It's very important that your angle is correct, and that's partly due to how high the blade is sticking up. The best way to test this is to use a Sharpie, mark the edge, and then run your stone across it. Ideally, you should remove about 1/4 of your markings from the edge. If it only hits the edge, your angle might be a little bit too steep, so you might have to lower the blade just a little bit. Take a look at the sample here. So when I sharpen, I don't have a very heavy hand, so I never worry about protecting the edge. I experimented using blue tape, and it seemed to work just fine. I was able to sharpen quite a number of blades before I saw any wear and tear. So I feel that it was easier for me to just replace the tape when it wears down than to fuss with aluminum foil or any form of protection. If you're going to build some fancy gadgets to protect the grit of the stone, just remember to take account the thickness of the material, because that changes the angle. Well, I think it's time to sharpen some blades and see how they work. I'm going to start off with the planer blades. It's a little bit more difficult with these disposable ones because you have to be real careful not to over sharpen and change the width of the blades. As you know, these blades are keyed and has locators to help you align the blades to a certain height. So if you're heavy-handed and using a coarse stone, you might want to count your strokes, but if your angle is set correctly, you're probably going to remove maybe a fraction of a thousandth of an inch. It's so small you're not even going to notice. So the way I sharpen is I use my water stone. I don't want to have it too wet, so I'm going to just dry it off with my sponge and then real quick. So it'll be somewhat dry. I'm just going to go from here and I'm just going to forward like this. Okay, this is a 4,000 stone. Nice edge on there. Then I'm going to go with the 8,000 next. Okay, so here's the 8,000. Dry it off real quick. Nice and dry. Same thing. So the next thing I want to do is I want to take the burr off that little edge here. So I'm going to take it to my water stone. And that's it. Now let's go see how it cuts. So I just changed the blade out. I'm going to lower this to another 30 thousandths of an inch. And I'm going to turn on the vacuum and I'm going to send this thing through. So I hope you're ready for this because this is going to be so freaking awesome. With these blades sharpened to 8,000 grit polish, I mean,